percent. Per is for, cent is nothing but every 100. If you are comparing every value with 100, then it is called percentage. A percentage is nothing but A by 100. A percentage is nothing but A by 100. Let us take fractions and percentages. There are some better methods if answer options are there. Assuming that answer options are not there, we will do fractions and percentage. 1 is nothing but 100 percentage. 100 by 100 is 1. 1 by 2. 1 by 2. If it is fraction is there. If there is a fraction in the question, right, I need to convert into percentage. I will multiply by 100 percentage. 1 by 2 into 100 is nothing but 50 percentage. 2 by 2 is 1. 1 by 3. 1 by 3 into 100 is 33.33 percentage. Right? Now, this is becoming a recurring decimal. I will come back to it. 2 by 3. 2 times 33.33. 66.66. Again, it is becoming recurring. The way I am explaining in the class, the same way write down in your notebook. Exactly same way write down in your notebook. 2 by 3, 66.66. Next it is 1 by 4. 1 by 4 into 100 is 25 percentage, which is terminating decimal. 2 by 4 is 1 by 2. 3 by 4. 3 times 1 by 4. 3 times 25 is 75. This is a terminating decimal. This is a terminating decimal. The one where I kept a star mark, it is nothing but a recurring decimal. 1 by 5. 1 by 5 into 100 is 20 percentage. 2 by 5 into 100 is 40 percentage. 3 by 5. 3 by 5 into 100 is 60 percentage. 4 by 5 into 100 is 80 percentage. All are terminating decimals. 1 by 6. 1 by 6 is 16.6666 percentage. Again, it is a recurring decimal. The value is getting repeated. 2 by 6 is 1 by 3. 3 by 6 is 1 by 2. 4 by 6 is 2 by 3. 5 by 6. 5 by 6 is nothing but 1 minus 1 by 6. 1 is 100 percentage. This is 16.66. This is nothing but 83.33333 percentage. Anything where I am keeping star mark, they are all nothing but a recurring decimal. I will come to the point after I explain everything. What is the difference between the star mark and an arrow? These are all terminating decimals. These are all terminating decimals. These are all terminating decimals. Anything which I kept in star mark, it is nothing but a recurring decimal. 5 by 6 is 83.33 percentage. Right? Now, the most important percentage. Listen carefully, sir. Now, listen carefully. 1 by 7. 1 by 7. 2 by 7. 3 by 7. 4 by 7. 5 by 7. And 6 by 7. 1 by 7, 2 by 7, 3 by 7, 4 by 7, 5 by 7, 6 by 7. All will give you recurring decimals, right? What recurring is nothing but repetition. I'll write down that point after this one. 5 by 7 and 6 by 7. It's very, very easy to remember. If 1 by 7 is there, for me to convert into percentage, I will multiply by 100. 100 divided by 7. 7 14s are 98. Dot, it is nothing but 20. 7 2s are 14, 60. 7 8s are 56. And so on, this process will carry. You don't need to do all this. Now see here, answer is nothing but 14.2857. Answer is nothing but 14.2857. How you got 14.2857? By dividing 100 by 7. Now, listen carefully. How to determine 2 by 7? Take the numerator 2. Multiply by 10. What is 2 tens are? 20. 7 goes how many times in 20? 7 2s are 14. 7 3s are 21. How many times maximum it is going in 20? 2 times it is going. Where is the digit? Here. How many times it is going? 2 times. Write down this digit and the next digit. Dot the remaining digits in the serial order. 28.5714, 28.5714, 3 by 7. Take the numerator 3. 3 multiply by 10. 3 tens are 30. How many times 7 goes in 30? 7 fours are 28. 7 fives are 35. How many times it is going? 4. How many times it is going? And the next digit, dot the remaining digits in serial order. I kept star mark. It is a recurring decimal. Recurring is nothing but repetition. The digits are getting repeated. 4 by 7. Take the numerator 4, multiply by 10. 4 tens are 40. 7 goes how many times? 5 times. 5 and the next digit 57.1428 percentage. 57.1428 percentage. 5 by 7. Take the numerator 5. Multiply by 10. 5 tens are 50. 7 goes how many times? 7 times. Where is the digit here? 7. Write down this digit and the next digit. Dot the remaining digits in a serial order. Remaining digits in a serial order. 6 by 7. Take the numerator 6. Multiply by 10. 6 tens are 60. 7 goes how many times? 8 times. 85.7142. 85.7142. I hope the logic is clear. All you have to do is just to find out 1 by 7 value and the same digits are repeated. Same digits are repeated. Again I am saying for the second time. 2 by 7. Take the numerator 2. 2 goes multiply by 10. I ideally have to multiply by 200. I will get 7 28s are 196. So if I multiply by 10, same value I will get. 2 tens are 20. 7 goes how many times in 20? 7 twos are 14. 7 twos are 14, right? So 2 and the next digit 28.5714. I hope everybody understood the mnemonic to find out these values. 3 by 7. 3 tens are 30. 7 goes how many times? 4 times. 42.8571. Everybody kindly reply in the live chat if this logic is clear to you. If this logic is clear to you, kindly reply. If this logic is clear to you, kindly reply. Again I am repeating one last time. 3 by 7. Take the numerator 3. 3 tens are 30. 7 goes how many times in 30? 4 times. Write down this digit and the next digit. Dot the remaining digits in the serial order. Remaining digits in the serial order. 7 fives are 35. 5 and 7 dot 1428. 142857. These digits are getting repeated. There is a 6-digit number which will have leftmost one. This is multiplied by 3. If I multiply this by 3, I will get another 6-digit number where the rightmost is 1. Let this number, I will call it as P. Let this number, I will call it as P. Let this number, I will call it as Q. Let this number, I will call it as Q. Question is, find the digital sum of P. Find the digital sum of P. Most of the students took a lot of time to solve this question, but actually it's an easy question. 3, 5, 7 and 9. 3, 5, 7 and 9. 1 A, B, C, D, E. Number I will call it as P. There is a 6-digit number where the leftmost is 1. The number is multiplied by 3. I will get another 6-digit number where leftmost one became the rightmost one. Remaining 5 digits remain as it is. So what is the digital sum of the number P? Listen carefully, sir. One beautiful way to solve this problem is, what is the digital sum of these number? Right? Digital sum is nothing but 1 plus A plus B plus C plus D plus E. What is the digital sum of this number? This is nothing but A plus B plus C plus D plus E plus 1. Can I say that this number digital sum is same, only the order of the variables is changed. 2 plus 3 plus 4 is the same as 3 plus 2 plus 4. So the first observation is digital sum of P is equivalent to digital sum of Q. I hope it is clear. Digital sum of P is equivalent to digital sum of Q. First option 3. If I substitute 3 into 3, 9. 3 and 9 are not same. 5. 5 3s are 15. These question digital sum and these answer digital sum, they both should be same. 5 is not possible. 7. 7 3s are 21. 2 plus 1 3, not possible. If I take 9, 9 3s are 27. 2 plus 7 9. Answer is nothing but 9. This question can be solved in 5 seconds if you look at the question through a different prism altogether. These digital sum and these digital sum both are same. From where I got this idea? Because he is asking the question, find the digital sum. So what I did is, I checked it out, what is the digital sum of P. Then I realized that digital sum of P and digital sum of Q, just the order of the variables is changed. Just the order of the variables is changed. So digital sum of P and digital sum of Q, they both are same. Digital sum of P and digital sum of Q, they both are same. I hope the idea it is clear. They both are same. The first point. They both are same. Another way to look at it is, now think logically, method number 2. Method number 2. 1 A, B, C, D, E into 3. Another is finding the values A, B, C, D, E ending with 1. E is a variable. E multiplied by 3, I should get 1. Which value E will take? E is 1. 1 3s are 3. E is 2. 2 3s are 6. E is 7. 3 7s are 21. 7 3s are 21. 2 carried. Here it is 7. Like that you have to find out the values of A, B, C, D. Don't use this method. This is a cumbersome method. Method number 3. Just now we discussed 1 by 7 is nothing but 14.2857. 3 by 7 is nothing but 42.8571. 42.8571. Now if you observe, listen carefully, sir. This is a very beautiful one. This is a 6-digit number where the leftmost is 1. 1 by 7 became 3 by 7. I multiplied by 3. I got another 6-digit number where the leftmost one became the rightmost one. Remaining digits remain as it is. I hope it is clear. Exactly, that is the reason I took this question. So 142857. Exactly, if you solve it, you will get the same answer. 142857. 142857. What will be the value? 7 plus 5 12. 12 plus 8 20. 22 26 27. 2 plus 7, what is the digital sum? 9. I hope just that based upon 1 by 7, 3 by 7 logic, I developed this question so that students will understand 1 by 7 is nothing but 14.2857. 2 by 7, take the numerator, multiply by 10. 2 tens are these for you, Rakesh. Right? 2 tens are 20. 7 twos are 14. 28.5714. Take how many times it is going in 20. Write down the next digit. Dot the remaining digits in the serial order. Dot the remaining digits in the serial order. 3 by 7. 3 tens are 30. Answer is 42.8571. 3, Rakesh, one more example. 3 tens are 30. 7 goes 4 times in 30. 4 times and the next digit 42.8571. I hope the idea it is clear. Now write down. Now write down. If P is a prime number. If P is a prime number. If P is a prime number. 1 by P is a recurring decimal. 1 by P is a recurring decimal. Is a recurring decimal when P is not equivalent to 2 comma 5. When P is not equivalent to 2 comma 5 or powers of 2 and 5. Right? 1 by P. Please write down this point, sir. 1 by P. Sorry. When 1 by P, it is a terminating decimal. It is a terminating decimal. It is a terminating decimal. When P is equivalent to 2 comma 5 or powers of 2 or powers of 2 comma 5 and 2 and 5. Please make a note of it, sir. 1 by p is a recurring decimal when p is not equivalent to 2 comma 5. 1 by p is a terminating decimal when p is 2 comma 5 or powers of 2, 5, 2 and 5. Suppose if it is 1 by 7. 7. P is not equivalent to 2 comma 5. Exactly this will give you a recurring decimal. The digits will get repeated. Suppose if it is 1 by 50, it is there. 1 by 50 is 1 by 2 into 5 square. This is a combination of 2 and 5. So this will give you terminating decimal. He will ask you which of the fractions will give you terminating or a recurring decimal. Suppose if it is 1 by 12. 1 by 12 is combination of 2 and 3. If the denominator only when it is a combination of 2 and 5. Only when it is a combination of 2 and 5, you will get the answer. Either only 2 or only 5 or only 2 and 5. I will get a terminating decimal. In all the other cases, I will get a recurring decimal. 3 is present. So, if the denominator contains a prime number other than 2 and 5, what is the answer I will get? Recurring decimal I will get. A recurring decimal I will get. Please take a screenshot of this extremely important key point. If p is a prime number, under what cases I will get a recurring decimal? Under what cases I will get a terminating decimal? 1 by 21. It is 3 into 7. Denominator is other than 2 and 5. So this will give you answer recurring decimal. This will give you answer recurring decimal. I hope the idea it is clear. Right? Most of the concepts you will not find in the regular textbook and you know it very well. No repeat telecast. 2 into 5 square terminating decimal. Now let us solve a question. I hope right now you have understood the importance of a star mark. Which of the following are terminating or recurring decimals? Which of the following are terminating or recurring decimals? 5 questions we will solve under this category. Right? When you take a fraction can result in a terminating or recurring. 7 by 45, 9 by 32, 13 by 65, 93 by 19, 432 by 123, 432 by 123, 123. Listen carefully, sir. You can also take one more thing. 17 by 222. 17 by 222. Which of the following are terminating or a recurring decimal? Only attack the denominator. Denominator it is 9 into 5. 3 square into 5. Only it should be combination of 2 and 5 or 2 or 5. So these are nothing but recurring decimal. These are nothing but recurring decimal. 32 is 2 power 5. These are nothing but a terminating decimal. These are nothing but a terminating decimal. 65 is 5 into 13. 5 into 13. 13 is a prime number. So, other than 2 and 5, these are nothing but a recurring decimal. 19 is a prime number. So, these are nothing but a recurring decimal. These are nothing but a recurring decimal. Please put a star mark on both of these. Both of these are exam related questions. Only the values I changed. The concept I will discuss right now. 432 by 123, 123. 17 by 222. 17 by 222. Now see here. Please write down, sir. Note. These both are examination questions. Let us discuss a concept. Suppose if I say reminder when 10 cube divided by 7. 10 cube divided by 7. 7 ones are 7. Remainder is 3. 3 cube is 27. 27 divided by 7. 27 divided by 7, right? 1 minute. Sriram is telling third one is a terminating decimal, third one, right? Okay. Third one, please change the question to 23 by 65. I am taking the numbers where numerator and denominator are co-prime to each other. In hurry, I took it as 13, right? We are taking the cases where the numerator and denominator are co-prime beta. In hurry, I took it as 13 and 65, right? These both are not co-prime. Please change the question to 23. Thank you for correcting, right? 23, right? Please change it to 23 by 65. 23 by 65. All the numbers, whatever I am taking, thank you, Sriram, for pointing out the mistake, right? 23 by 65. Now, see the logic. 23 by 65. That variety we will solve little later. First, we are discussing the questions where the fraction is of the form numerator by denominator. First case, I am still in the first case. Numerator and denominator are co-prime to each other. Second case, numerator and denominator are not co-prime to each other. So, we are still in the case number 1. What do you mean by co-prime? HCF of the numerator and denominator, it is nothing but 1. HCF of numerator and denominator, it is nothing but 1. So, we will solve this case. Let me do it in the next slide. Reminder 1. 10 power 3 divided by 7. Listen carefully. 7 ones are 7, right? Reminder 3. 3 cube is 27. 27 divided by 7. 7 fours are 28. Negative remainder is minus 1. Next one. Reminder 1. 10 cube divided by 11. 11 ones are 11. Negative remainder is minus 1. Minus 1 cube is minus 1. Yesterday we discussed remainder all the 5 varieties. Remainder 10 cube divided by 13. 13 ones are 13. Minus 3 cube. Minus 3 cube is minus 27. Minus 27 divided by 13. 13 twos are 26. Remainder 1. So minus 1. I got the case minus 1 and minus 1. For which all numbers I got? 7, 11 and 13. Suppose if the question is remainder 1, 1, 2, 3, 1, 2, 3 divided by 7. 1, 2, 3, 1, 2, 3 divided by 7. Can I write it as 1, 2, 3 into 10 cube plus 123 divided by 7. 10 cube divided by 7 is minus 1. Minus 123 plus 123. What will be the answer? 0. Minus 123 plus 123. What will be the answer? 0. Please write down these extremely important point. Any three-digit number written even number of times. Any three-digit number written even number of times. Any three-digit number written even number of times is always divisible by 7, 11, 13 and also it's a combination. 7 11s are 77. 7 13s are 91. 11 13s are 143. 7 into 11 into 13, which is nothing but 1001. Very, very important point. Please make a note of it. Any three-digit number written even number of times, it is always divisible by 7, 11 and 13. 7, 11 and 13 and its multiple. 7 into 11, 7 into 13, 11 into 13 and 7 into 11 into 13. I hope the proof is clear. Now 432 divided by 1, 2, 3, 1, 2, 3. This is a three-digit number written 2 times. So that means it is divisible by 7, 11, 13. Denominator is a prime number other than 2 and 5. So answer is, it will give a recurring decimal. Right? You make it into 431, sir. Otherwise again it will become multiple of 3. change the question to 431. I hope the idea is clear. Again, we will mix case number 2. I don't want to do it. 431. If I take 432, it will be divisible by 3. These also divisible by 3. I don't want to do it. 431. Make a change. 431 by 123, 123. Any 3-digit number written even number of times is always divisible by 7, 11, 13, 77, 91, 143 and 1001. Numerator and denominator are co-prime to each other. Next one. Suppose see here. Another way, this was asked in one examination. Let us do just one more. Divisibility rule. Divisibility rule for 99, 101. Divisibility rule for 99, 101. All these are useful in your right calculation things. That also we will see. Divisibility rule for 99 and 101. These are nothing but 10 square divided by 101. 100 divided by 101. It is minus 1. Suppose if the question is, instead of 3-digit number, if it is a 2-digit number, 1212 divided by 101. These are nothing but 12 into 10 square plus 12 divided by 101. 100 divided by 101. It is minus 1. Minus 12 plus 12. It is nothing but 0. Another very important point. Any 2-digit number written even number of times. Any 2-digit number written even number of times. Any 2-digit number written even number of times is always divisible by 101. Please write down this point. Any 2-digit number written even number of times is always divisible by 101. For example, 73 divided by 1212. 73 divided by 1212. Question is, we have to check whether it is terminating or recurring. 1212. Any 2-digit number written even number of times. It is divisible by 101. It is a prime number. So answer for this question is recurring decimals. Recurring decimals. Most of the teachers ignore telling how to solve terminating and recurring. We are so habituated only finding this one, right? This is a 4th class concept, right? Only they will discuss these varieties, right? But there is a huge concept that is there. 73 divided by 1212. I hope this is also clear, right? When time permits, I will discuss 19 and 37 at the end. Just we will park that. Now, because Sri Ram has identified that 13 by 65, let us take some kind of questions. 17 by, for example, 7225. 68 divided by 7225. What if the numbers are not co-prime to each other? 68 divided by 7225. These are nothing but 17 into 4. These are nothing but 85 into 85. 85 into 85. 17 ones are, 17 fives are. So these are nothing but 4 divided by 5 into 17. Right? Denominator contains 17 as a prime number. So answer is nothing but it is a recurring decimal. We are discussing the case where numerator and denominator. We are discussing the case where numerator and denominator are not co-prime to each other. We are discussing a case where numerator and denominator are not co-prime to each other. Suppose one more example. Another example. 87 divided by 3364. These 29 threes are. These 58 into 58. So these nothing but 29 twos are. These nothing but 3 by 2 into 29. 29 is a prime number other than 2 and 5. These are all nothing but a recurring decimal. These are all nothing but a recurring decimal. I hope this concept is clear. If a fraction is given to you, If a fraction is given to you, which has numerator and denominator, which one will be recurring? Which one will be terminating? I am sure right now you will be able to identify it after knowing these concept. Kindly reply in the live chat if this concept is clear. Recurring decimal and terminating decimal. Everybody kindly reply in the live chat if this concept is clear to you with an yes. If it is not clear to you, kindly ask me a doubt. Kindly ask me a doubt. I will be very happy to help your doubt. Right? Generally, it is said that in online, doubts cannot be asked, but each and every student's valid doubt, I will personally call their name and I will explain the doubt. 12.5 percentage. 12.5 percentage. 3 by 8. 3 by 8 is 3 into 12.5 percentage, which is 37.5 percentage. 2 by 8 is 1 by 4. 4 by 8 is 1 by 2. 5 by 8. 5 into 12.5, which is nothing but 62.5 percentage. 6 by 8 is 3 by 4. 7 by 8 is 7 into 12.5. It is nothing but 87.5 percentage. Please write down. Sriram, no, we cannot say just by looking at a question.